Welcome to Golden Software's demonstration video for Surfer 9 Part 3. In this demonstration, I'll be covering the topic of gridding XYZ data to produce a grid file. Grid files are necessary to create 7 of the 10 map types in Surfer. You can download grid files from the internet, such as USGS DEM files or SRTM data. You can produce grid files in other software packages, such as Esri products, or you can create grid files directly in Surfer using an XYZ data file. To grid the data in Surfer, the data file must be organized so that the X, Y, and Z data are in 3 separate columns, and it must be saved in a supported data file format, such as a text file, a CSV file, a database file, or an Excel spreadsheet. To create a grid file, go to Grid, Data, select your data file, and click Open. The Grid Data dialog box will open. In most cases, the default gridding parameters are suitable. However, you can fully customize your grid. In the Data Columns section, you can specify which columns in your data file are the X, Y, and Z columns. If you have duplicate data or wish to apply a data exclusion filter, click the Filter Data button. Here you can tell Surfer what to do with duplicate data. For example, you could tell Surfer to keep the first data point in the data file and discard the other duplicate data points. Or you can select from any of these options. For example, you could tell Surfer to average the duplicate data points. You can also specify the tolerance for what Surfer would consider a duplicate data point. You can also enter a data exclusion filter. For example, you can choose to exclude all data points in the data file with a Z value of -999. Click OK when you are done. If you don't remember which columns contain the X, Y, and Z data, or you need to refresh your memory on the data, just click the View Data button to view the data. You can close the View Data window by clicking on the red X in the upper right corner of the window. If you wish to create a statistics report about the data, click the Statistics button and a data statistics report will be generated. Close the report by clicking on the red X in the upper right corner. If the Grid Report checkbox is checked, Surfer will generate a report after gridding is completed with information about your data and the grid file generated. Surfer offers you a choice of 12 different gridding methods. What you choose for the gridding method will depend greatly on your data and what you would like the output to look like. There is no one best gridding method to use for all datasets or for any particular type of industry. However, there are some instances where some gridding methods may be more suitable than others. The default method, which is kriging with a linear variogram, was selected as a good method as it produces a good-looking map for the majority of datasets. However, it is not an exact interpolator and can extrapolate grid values beyond your data's original Z range. For example, if your data goes from 0 to 100, the Z range of your grid file may be from -5 to 105. If you wish to use a more exact interpolator that does not extrapolate Z values beyond the range of data, you can try the inverse distance to a power method, natural neighbor, nearest neighbor, or triangulation with linear interpolation. If you like the look of the map produced with the kriging gridding method, but wish to include a fault file, then minimum curvature might be the best option for you. If your data is already on a regularly spaced grid, you might want to try the nearest neighbor gridding method. Then set the grid spacing equal to that of the spacing between your data points. There are many reasons why you might choose one gridding method over another. Each map will look slightly different with each gridding method, and it is really up to the personal preference of the user. For this demonstration, I will use inverse distance to a power. Once you've selected a gridding method, you can access additional options for the gridding method chosen by clicking on the Advanced Options button. The options available under Advanced Options will change depending upon the gridding method chosen. Some of the more common options include a General tab. On this page, it shows you gridding-specific options, and in some cases, an anisotropy section, which allows you to specify the ratio and angle for the preferred orientation of the data. The search page controls which data points are considered by the gridding operation when interpolating the grid nodes. If you have fewer than 250 data points, usually the no search option is the most appropriate, and the gridding algorithm uses all the data to calculate the grid node z-values. If you have between 250 and 750 data points in your data file, then the default is to use a search. But you still have the option to specify no search if you want. If you have more than 750 data points, you must use a search. The search rules define the number of data points to include when interpolating a grid node z-value. The search ellipse defines the shape and size of the searchable area around each grid node to use to calculate that node's z-value. Data points that fall outside the search ellipse for a grid node are not considered when calculating that grid node's z-value. If no data points fall within the search ellipse, then that grid node is blanked. The breaklines and faults, or breaklines page, allows you to include a breakline or fault file when gridding data. The breakline and fault files must be saved in BLN format to use during gridding. Some gridding methods support breaklines, some support breaklines and faults, and some don't support either of them. To help understand the difference between breaklines and faults, breaklines occur when there is changes of slope on either side of the line. This might be at the top of a ridge or at the bottom of a riverbed. Breaklines have x, y, and z values for each vertex in the line in the BLN file. This is the only time when z information is used in a BLN file. With breaklines, Surfer can look across the breakline to the other side for data points to use when calculating grid node z values. The x, y, z points of the breakline file are also included as data points during gridding. Faults, on the other hand, occur when there are differences in z-values on either side of the line. This could be because of a geological fault or another reason such as a landslide. Faults have only x and y values in the BLN file. When gridding, Surfer sees the fault as a stop. It cannot look across the fault to the other side for data. It can go around the fault, but the distance will increase, and the data on the other side of the fault will have less of an effect on the grid node z-values. To select a breakline or fault file, simply click the yellow Open Folder icon, select your BLN file, and click Open. Adjust any of the advanced options you wish and click OK. Click the Cross-Validate button to perform cross-validation on your data. Generally, cross-validation can be considered an objective method for assessing the quality of a gridding method, or to compare the relative quality of two or more candidate gridding methods. In Surfer, cross-validation can be used with all gridding methods. You can save the results by specifying the file name and location in the Cross-Validation Results file section. For details and more information on the cross-validation parameters, please click the Help button to open the Cross-Validation Help page. The Output Grid File section allows you to specify the output grid file name and file path. By default, Surfer will create a Surfer grid file. However, you can click the yellow Open Folder icon, browse to any file location, type in the file name, and choose any of the supported grid formats to save in. Click Save. The Grid Line Geometry section allows you to specify the extents and resolution of the grid file. You can choose to set a particular x and y minimum and maximum value. This is useful if you're trying to match the extents of one grid file to another grid file, or if you want the grid file to be exactly a particular size. You can also choose the grid line spacing, which determines the number of grid lines. The smaller the grid spacing, the more grid lines you have in your grid file. By default, Surfer sets 100 grid lines in the longest direction. The spacing values between the directions to be equal, and then calculates the number of lines in the shorter direction. You can increase the number of lines up to 32,767 grid lines, but the more grid lines you have, the more memory it takes to create the grid file. When you're finished setting your parameters, click OK to create the grid file. You'll be notified when the grid file is created, and, if specified, the grid report will open. The grid can now be used to create maps, calculate volumes and areas, or perform other grid functions. This concludes my demonstration of grading data in Surfer.